In this exercise, we will examine the position in the network of each node representing the families in the 15th century Florentine Italy. The purpose of this exercise is to compare these families based on different criteria. So we're going to create a data frame in which the index is the family itself, and then the columns would be the degree coefficient, clustering coefficient, closeness, centrality, betweenness, centrality, and page rank of each family. And then we want to rank the families across these criteria, and we want to report the family that ranks first for each criteria. So the very first step is to import network X and then load the network from the file. So I'm going to load the network from the GraphML file, GraphML data / Florentine.graphml. I can draw the network, but that's not needed. We've drawn the network before, we know it very well. So let's go ahead and calculate these different metrics. First, we're going to calculate the degree, which is done by calling the function degree here. So degree of network NET, and that's the degree. Next, we're going to calculate the clustering by calling the function clustering on the network. And those are the clustering coefficients of the nodes representing the families. And then we're going to do the closeness centrality, so I'm going to call it closeness. And we're going to call the function closeness centrality here on the network. So that's closeness. The next step is to do the betweenness centrality, so I'm going to call this one betweenness. Because double N, centrality of network. And lastly, we're going to do the page rank. So page rank will be nx.pageRank of our network. So now we need to assemble all of these numbers together in a data frame so that we can analyze the data collectively. So there are multiple ways of doing it. We can create a pandas data frame. I'm calling pandas. We're not sure if I imported pandas. I just want to double check. I need to import pandas here. And then I am going to create a data frame by passing these as a dictionary of column name, for instance degree, to the dictionary itself. The only one that I'm not sure about is degree, because the result itself is not a dictionary. It looks like a dictionary, but it's of a type degree view, so I'm not sure if this is going to work. I'm going to try, so I'm going to map clustering here to clustering. See if that works. So this one did not work. This one worked fine. So we have to kind of find a way to deal with the degree view. Let's finish the remaining ones. So the remaining ones are closeness. Map it to closeness here. Betweenness. Betweenness. We'll map it to betweenness. And then page rank, I'm going to map it to page rank here. Forget the comma. Alright, so let's call this one the data frame here. Next, let's take a look at degree here. That's the one I'm not sure about. It says it's a degree view. So let's see if it has any functions that help us convert it to a dictionary here. Let's try to make that conversion explicitly. Okay, so that worked. That converted to a degree, so I'm going to just map degree to dictionary of degree And that's my data frame. Okay, so next we're being asked to report the family that ranks first in each criteria. So in all of these questions, we are going to sort in a descending order. So the highest degree, the highest clustering, the highest closeness, the highest betweenness, because that's usually what's of interest. The higher the value is, the more central, the more influential, the more brokering, the more powerful a node is in the network. So what I'm going to do, well, for instance, let's do degree. We're going to do sort values degree ascending is false, and that's the Medici. So we can do index 0 to get that in degree. Okay, so based on degree, Medici family comes first. And then we need to do this for clustering, closeness, betweenness, and page rank. So what I'm going to do, I'm going just to write a loop for each, because I'm going to go over the columns eventually in data frame.columns. And what I need here is basically the column name, which will give me the measurement here. So I can do something like this, and either if I want to print it, I can just print column and a sorted value, or I can assemble them in a list or a dictionary if I need these results to be saved. So based on degree, we've got the Medici. Based on clustering, we get the Peruzzi. And based on closeness, betweenness, and page rank, it's actually the Medici family. So in all of these criteria, except that clustering, Medici family kind of reigns supreme here. The Peruzzi family is the only one that ranks first in clustering, simply because it sits in a densely clustered area in the network. So that also serves to illustrate the usefulness of these methods. We know that the Medici family was the most powerful family in the 15th century Florence in Italy.